Who's the best little spinner bait in all the world? Who's the best little Terminator Colorado with a leaf blade combination in the whole wide world? You are. Oh, yes, 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 you are.
Sam.
Oh. Sorry, guys. I was just, yeah, I got nothing. I'm just a weirdo. But, since you're here anyways, let's talk about central tendency. We started our talks last time about probability, and I told you that probability was the likelihood that an event would happen. So we're going to go kind of a step deeper, and we're missing things, don't get me wrong, because we're in distance learning. We're gonna start onto this path, which is another thing that I feel like is really, really important for you to understand, is central tendency and how that relates to your probability and statistics moving forward. So central tendency, as you may or may not know, and is outlined in my packet, is mean, median, and mode. Those are the measures of central tendency. Well, you've talked about those a lot. You've calculated those a lot. I don't really care about that. What I care about is helping you to understand why we care about that. So let's look like right here. We have an X axis and we have a Y axis. Then we have a bunch of data points. I'm going to use this in our next video too. But let's just look at them. We could figure out the X's, we could figure out the Y's, we could calculate averages, we could calculate the mean, we could calculate the median, we could calculate the mode, we could do a million different things with the Y values and the X values. But it doesn't really mean anything. It's just all meaningless data unless we can get measures of central tendency. And unless we can extrapolate them to make predictions or to understand our data set better. Let's take, for example, this data set. Well, we can average it with a line. It's called a line of best fit. So I have approximately the same amount of dots above this line as I do below it. Now it's not perfect, but it's pretty close. This line would be a good approximation of a central location in this data set or this distribution. Well, if I knew the mean and the median and the mode, I would be good with that stuff. And then I could take that stuff and I could calculate more advanced measurements like standard deviation or variance, which are two ways to, again, measure things from that mean, that average, that central tendency of a data set. Because really what I want you to take home from this is that the mean, the median, and the mode and all that stuff was great, and it was cool finding it, and I could have you guys find that stuff, but that's not really why this data exists. This data exists for this word, tendency. We can use data and probability and statistics to make predictions. Now, that all starts from understanding the basics of the data, like the central tendency. But from there, we can derive more advanced calculations from that data set to make predictions and to understand it better. Let's just think about something. Say, for example, the average person works 38 hours a week. That's great, but that's a really broad piece of data. It doesn't really give me a lot. I could find more advanced things like the average 27-year-old who lives in Kent County works 36 hours a week, or the average 45-year-old in Wayne County works 52 hours a week. I could find differences there, and then I could compare them. And I could compare them against a data set, or an average, or a standard deviation. And I can get all these calculations to understand my data better. Because remember, probability and statistics is not an answer. It's just a guide. It helps you to guide in decision making, and it helps you to understand the world that's happening around you a little bit better. If this was an example of temperature and ice cream, we would be able to derive a very likely scenario where the hotter it gets, the more ice cream people get. If we don't start with measures of central tendency like mean, median, and mode, then we don't ever get to standard deviation and variance and confidence intervals and all these really great things that I wish we were talking about right now. So I want you to understand that the math you learned in 8th grade and 9th grade and throughout all of your probability lessons are leading you to a place where you're studying deviation and correlation. Speaking of correlation, It's going to be our next video. Thanks for hanging out with me, guys. We'll talk to you later.